Right now, something extraordinary is unfolding in our solar system, concealed just behind the sun. Tomorrow, October 21st, 2025, the 5 kilometers wide object known as 3I Atlas will reach solar conjunction, aligning perfectly on the opposite side of our star from Earth. For over a week, it will vanish from our view, unseen, untracked. Harvard astrophysicist Avi Loeb suggests this timing is far from random. In just 9 days on October 29, 3I, Atlas will hit perihelion, its closest approach to the Sun, absorbing a staggering 33 gigawatts of solar energy. This is the precise moment astronauts exploit for gravity assist maneuvers, the ideal point for a spacecraft to fire its engines for maximum efficiency. Yet during this critical window, we'll be blind to its actions. On October 13, 2025, exactly 8 days ago, researcher David Sereda reported something astonishing. Light pulses, not random flickers or natural brightness shifts, but a deliberate pattern. 5 flashes, then 8, then 13. The Fibonacci sequence emanating from an object hurtling through our solar system at 200,000 kilometers h. That same day, marking the 108th anniversary of the Miracle of the Sun in Fatima, Portugal, NASA's Solar Dynamics Observatory inexplicably went offline. This high-resolution imaging system was set to capture unprecedented images of 3I Atlas during its Mars flyby, but those images remain unreleased. On October 13, 1917, 70,000 witnesses, including skeptics and journalists, reported seeing the Sundance spin and plummet toward Earth. Before returning to its place, a phenomenon documented in secular newspapers and photographs of awestruck crowds. In 65 days on Christmas morning, 2025 3I Atlas will align with Earth at an angle mirroring the slope of the Great Pyramid of Giza. These aren't speculations. They're precise measurements, verified trajectories and alignments with a probability of coincidence calculated at less than 1%. 8 anomalies challenge everything we thought we knew about interstellar objects. Today, as 3I Atlas slips behind the Sun, we'll dissect each one. If this is already sending shivers down your spine, please hit the like button, subscribe, and share where you're tuning in from in the comments, along with the time and your thoughts. Are we being visited? Help spread this message by sharing on X, Facebook, Reddit, or with someone who needs to hear it. Thank you for supporting our community. 8 days ago, David Sereda, while monitoring 3I Atlas through multiple observational channels, detected structured light emissions, not the gradual dimming of a rotating comet or the erratic flares of outgassing, but a sequence 5 pulses, then 8, then 13. The pattern repeated unmistakably, forming the Fibonacci sequence 1, 2, 3, 5, 8, 13, 21, 34, 55, where each number is the sum of the 2 before it. This sequence, found in nautilus shells, sunflower seeds, and galactic spirals, encodes the golden ratio 1.618, a proportion woven into the fabric of reality. Sereda, who collaborated with MIT physicist Bogdan Maglic on nuclear fusion, instantly recognized the significance. But the timing deepens the mystery. October 13, 2025 marks exactly 108 years since the Miracle of the Sun in Fatima, Portugal, when 70,000 people witnessed the Sun's inexplicable dance. This wasn't folklore. Photographs show crowds gazing skyward, and newspapers documented the event. The number 108 resonates further, tied to the frequency octave of 432, a number revered in ancient temples and musical tuning systems. Sereda claims a vision guided him to add 432 days to October 19, 2024, landing on December 25, 2025. Christmas Day, when 3i Atlas will reach its closest approach to Earth, aligning at the precise angle encoded in the Great Pyramid of Giza. This sounds fantastical. Visions, miracles, pyramids, and coded signals from an interstellar object. Yet the data is real documented pulses, precise alignments, and a mathematical pattern too perfect to dismiss lightly. Every rational instinct screams that this is mere numerology, the human mind grasping for patterns in chaos. Perhaps it is, but certain facts demand attention, refusing to be dismissed. Serida's light pulse observations, meticulously documented and published, are verifiable. The timing is precise, undeniable. On October 13, 2025, 108 years to the day since the miracle of Fatima Serida reported his findings. The trajectory of 3i Atlas, a celestial enigma, is no less certain it will reach its closest point to Earth on December 25, 2025. The geometric alignment Serida describes can be calculated, cross-checked, and confirmed. This isn't about whether Serida fabricated his claims. The question is whether what he observed is real, and if so, what it signifies. The timing grows more unsettling. On that same October 13th, NASA's Solar Dynamics Observatory, a sentinel of the sun's ceaseless activity, went silent. Its public data feeds, which normally stream near real-time images and metrics, abruptly stopped. NASA cited technical difficulties. The spacecraft built to monitor solar phenomena without interruption was offline during the exact window when Serida detected what he calls Fibonacci pulses light signals, aligning with the mathematical elegance of the golden ratio. The feed has since resumed, but that critical gap persists, raising questions that linger like shadows. Coincidence. Technical failures happen, but the precision of this timing gnaws at reason. Days earlier, another anomaly unfolded. On October 1st, just 2 days before 3i Atlas made its closest approach to Mars, offering the clearest observation window until its Jupiter flyby in 2026, the US government ground to a halt. A shutdown furloughed over 15,000 NASA employees, 83% of its workforce, leaving only a skeleton crew deemed essential. NASA's website froze, and the high-rise camera aboard the Mars Reconnaissance Orbiter, poised to capture 3i Atlas at an unprecedented 30 km per pixel resolution, produced images that remain locked away unseen by the public. The European Space Agency offered a glimpse on October 7th, releasing images from its Mars orbiters. But these were disappointing, a fuzzy blur, barely sharper than Hubble's earlier distant shots. They lagged the detail HiRISE should have delivered. NASA's silence is deafening. Representative Anna Paulina Luna publicly demanded answers about the HiRISE images. White House Deputy Chief of Staff Stephen Miller, when pressed in an interview about whether the president had been briefed on 3i Atlas, sidestepped the question with practiced ease. Serida, in his Medium posts, insists these images hold the key to unraveling the object's size and nature. Yet, as of October 20th, 2025, they remain under wraps. The pieces align with eerie precision. Fibonacci pulses detected on October 13th, the Solar Dynamics Observatory's blackout on the same day, a government shutdown just before the Mars flyby, and the withheld HiRISE images. Serida ties these events to a prophetic timeline pointing to Christmas Day 2025 as a moment of cosmic reckoning. It's tempting to wave this away as conspiracy nonsense, except for one unshakable truth. The 7 other anomalies Serida references are not conjecture. They are documented, peer-reviewed, and have mainstream astronomers twisting into intellectual knots to explain them. At the heart of Serida's claims lies his hyperdimensional solar system model, a framework weaving the golden ratio into planetary orbits. He points to 3I Atlas's rotational period, 16.16 hours or 969.6 minutes, a number eerily echoing Methuselah's biblical lifespan of 969 years. Divide 969.6 by Earth's sidereal period of 365.256,363 days, and the result is 2.65457,388, the golden ratio squared with 99.5% accuracy. Serida insists this is no accident. It's a signal, a cosmic thread woven into the fabric of the universe, daring us to look closer. The question isn't whether to trust Serida's vision. It's whether the universe is trying to tell us something, and whether we're brave enough to listen. He asserts that 3I Atlas encodes a cosmic cipher, unveiling the solar system's hidden architecture, a celestial map where unseen planets dance at intervals governed by Fibonacci ratios. Most scientists would dismiss this as fantastical tuning out at the mere mention of such claims. Yet hyperdimensional planets rooted in biblical numerology and the golden ratio. That's not astronomy, it's mysticism, cloaked in mathematical garb. Serida, undeterred, insists his model precisely predicts the orbital rhythms of known planets. By weaving the Fibonacci sequence and golden ratio fractals, he aligns his framework with the number 591 linked to his wife Crystal, and overlays it onto a model tied to 969. From 3I Atlas, the differences between these numbers weave the Fibonacci sequence itself, mapping to both visible and concealed planets, he argues. Whether his model holds any truth is almost secondary. What matters is this: on October 13th, he witnessed something extraordinary. Light pulses flickering in a 58-Fontrine pattern. He shared this discovery on Medium that very day. The pattern mirrors the Fibonacci sequence. The date aligns precisely with the Fatima anniversary. His calculations pointing to Christmas Day are verifiable, open for anyone to scrutinize. Curiously, NASA's Solar Dynamics Observatory went offline during this observation window, and high-res images from the Mars flyby remain under wraps amid a government shutdown that struck at the most inopportune moment. Is Serida's interpretation correct? Does 3I Atlas broadcast a mathematical revelation unveiling a solar system structured by the golden ratio, complete with hidden planets? That seems improbable. But did he observe something tangible? Did an event on October 13th echo the 108-year anniversary of a widely witnessed anomaly? And does it hint at December 25th as a pivotal date? These questions are harder to brush aside. Consider the implications. We're discussing an interstellar object confirmed to originate beyond our solar system, tracing a path that multiple scientists calculate has less than a 1% chance of occurring randomly. This object now lurks behind the sun, invisible to ground-based telescopes during its perihelion, the moment it's closest to the sun, brimming with maximum energy for potential maneuvers or activity. It will remain obscured until early November. When it reappears, we'll see if its trajectory has shifted. We'll discern if it has fragmented, releasing smaller objects. We'll determine if it still behaves like a comet or if something stranger is afoot. If Serida's claims hold even a sliver of truth, if December 25th carries the weight, he suggests we have 65 days to brace for what that might entail. 65 days to track this object as it journeys from perihelion back through the solar system. 65 days to test if the pattern persists, if the Fibonacci signal is real, if the timing is prophetic, or merely another fleeting apocalyptic prophecy destined to fade. But here's what keeps you up at night. We have those 65 days only if NASA releases the data, only if the high-res images are made public, only if the global astronomical community can coordinate observations when 3-Eye Atlas emerges from the sun's shadow in November. Right now, during the most critical observation window, as this object reaches perihelion and harnesses peak solar energy, NASA is shuttered, the best images are locked away, and the object remains invisible. Coincidence, perhaps. But when coincidences pile this high, when timings align this precisely, when patterns fit this seamlessly, the word coincidence begins to feel hollow. It starts to sound like a shield we wield when we're reluctant to face the alternatives and those other possibilities, the ones we'll unearth through the 7 lingering anomalies. They're anything but soothing. They're jagged edges against the fabric of certainty, forcing us to question our fragile foothold in the universe. Are we truly solitary? Are we under watchful eyes dissected by intelligences that wield mathematics, geometry, and chronology like gods, rendering our pinnacle equations mere nursery rhymes? The Fibonacci spiral. 5A13. Flashes of light from an entity that defies existence, captured on a day of negligible import, arrowing toward a horizon laden with unfathomable portent. All unfolding in shadows as the intruder conceals itself in solar glare, while the visuals that could shatter our riddles languish in vaults sealed by governmental stasis and red tape labyrinths that mock plausibility with their impeccable choreography. The blackout decree. What shadows do they cloak? October the 1st, 2025. 2 days shy of 3-Eye Atlas's intimate brush with Mars. 2 days before the meticulously orchestrated gaze of astronomers worldwide. 2 days before the high-stakes lens would etch portraits at 30 kilometers per pixel portraits, poised to unveil the object's authentic girth and architecture. That dawn, the United States government invoked shutdown. Some 15,300 NASA souls absorbed furlough edicts. 83% of the agency's civil service dispatched to limbo. Solely the mission-critical few clung to their vigils. The synchrony, as Avi Loeb seethed with scarcely veiled ire, could scarcely have been more ruinous. Yet herein lies the alchemy elevating happenstance to suspicion. NASA's prelude assured that Mars flyby dissection demanded days, intricate pixel alchemy, spectral dissections, meticulous calibrations, and validations. These rituals demand patience. The Bureau primed the chorus aptly. Then on October 4th, scarcely 24 hours post-passage, NASA dispensed curated whispers to select media bastions. No visuals, no spectral revelations, no forensic dossiers, merely spoken sketches portraying 3-Eye Atlas as a pedestrian comet enacting rote cometary rituals. The verdict rang unequivocal: nothing anomalous. Proceed indifferently. The snag. Those dispatches flagrantly clashed with chronicles from myriad autonomous observatories etched across months. They defied Hubble's chronicles of anomalous solar jets. They scorned Keck Telescope's sightings of aberrant nickel exhalations untethered to iron. They spurned Loeb's computations, deeming the entity prodigiously ponderous to defy the thrust of its own venting. And they materialized sans evidentiary scaffolding amid fiscal paralysis, antecedent to the pinnacle clarity visual's gestation or unveiling. Convenient, scarcely scratches the surface. ESA, the European Space Agency, summoned 4 days to unfurl inaugural glimpses from the ExoMars Trace Gas Orbiter. When those apparitions materialized on October 7th, they beheld 3I Atlas, as anticipated, a nebulous luminosity etched against the stellar tapestry, the orbiter's lens pursuing the wanderer's drift. The CAS's instrument, with its 13.5 centimeter mirror, ensnared the luminous epicenter sprawling roughly 680 kilometers. Echoing Hubble's distant vignettes from months prior, yet from an intimacy of mere 30 million kilometers. The frames affirmed venting. They ratified dynamism. They ratified that 3I Atlas transcends inert obsidian tumbling silently. Yet they proffered scant granularity to pierce the enigma's heart. That acuity was destined for HiRISE, the high-resolution imaging science experiment perched aboard NASA's Mars Reconnaissance Orbiter. This sentinel, with its half-meter primary mirror, aligned flawlessly for the October 3rd rendezvous. At 29 million kilometers remove, HiRISE's acuity yields 30 kilometers per pixel. The apex pixel's blaze would tether the nucleus's radiant footprint, layer in albedo suppositions, and that datum births dimensions. And dimensions are destiny for Loeb's reckonings, posit that surpassing 5 kilometers span thrusts its heft into realms defying prosaic genesis. Ponder the precipice. Loeb's tally of 33 billion metric tons, his baseline for the entity's inertia, inferred from negligible, non-gravitational drift marks of floor. Vastness or density could swell it further. Should HiRISE unveil a nucleus eclipsing 5 kilometers discourse pivots from eccentric interloper to ontological outlier, we'd interrogate its very nativity. The actuarial odds of an interstellar behemoth, this colossal invading our domain, dwindle to infinitesimal wisps. The cosmic granary of rogue ices beyond Sol's grasp yields no forecast for colossi of this caliber, hurtling at such velocities to our threshold. So where dwell the HiRISE heirlooms 2.5 weeks post-rendezvous? As of October 21st, NASA withholds them. The refrain calibration arrears, shutdown sabotage, skeletal crews. These alibis ring rational. Data from probes traversing cosmic gulfs demands deliberation, particularly under duress. Yet ESA dispatched their bounty in 4 days, unencumbered by fiscal frost. And NASA orchestrated media murmurs in 24 hours despite professing epochs for substantive scrutiny. The dissonance summons specters. Pavel Zlatnik, etching on Medium, delineates what he dubs the information playbook, a ritualistic choreography for quandaries when visuals betray the orthodoxy, unveiling enigmas that imperil the canon. The choreography unfolds predictably. First, procrastination. Processing lingers. Validations beckon. Calibrations compel. Fortnights evaporate. Second, curated dissemination. Murmur to vetted heralds, verbally pre-visual deluge. Sculpt the saga. Mold the lens ere the unvarnished arrives, lest the masses forge forbidden verdicts. Third, labyrinthine hurdles. Fiscal eclipses, pecuniary pinches, manpower mirages, ever credible, eternally elusive as malice, yet uncannily punctual in their providence. Is this the script unspooling? Are we spectators to orchestrated opacity in vivo, or mere witnesses to procedural prudence entangled in chronological cruelty? The verdict resonates, for these aren't esoteric esoterica. We're dissecting an apparition that legions of savants whisper may transcend the terrestrial forge. We're dissecting trajectories etched with improbability, less than 1% odds of random alignment. We're unraveling chemical ghosts unseen in the wilds of nature. And we're staring down a vanishing window of scrutiny. Right now, 3i Atlas lurks in the sun's blinding corona, an elusive specter. When it slinks into view in early November, any whispers of deviation trajectory twists, fragmentation fissures, progeny of smaller shards will demand the foundational etchings from the Mars flyby to decode the chaos. Absent those high-rise revelations, we're adrift in cosmic fog instruments, idle truths, tantalizingly out of reach. The governmental freeze thawed officially on October 9th after 9 grueling days of stasis. House Speaker Mike Johnson's voice, laced with exasperation, lobbed the gauntlet to the Senate's doorstep. Their ballot to propel a stopgap funding lifeline crumbled 54-45, yawning 6 votes from the 60-vote chasm. Rinse repeat, another tally, another tumble, another tether, snapped in the chain of progress. In the interim, NASA's digital facade bore a stark decree, operations eclipsed by fiscal void. Staff could pilgrim to a sequestered shutdown sanctuary for scraps of solace, yet public data streams lay barren as a neutron star's husk. The Mars Reconnaissance Orbiter hummed on in splendid isolation, its robotic sinews flexing as scripted harvesting troves of telemetry in the void, but bereft of human hands to distill and disseminate those gleanings, evaporated into irrelevance phantoms in the machine. Repchen Anna Paulina, Luna pierced the veil with incisive barbs. Had the Oval Office absorbed briefings on 3i Atlas? What arcane dossiers did the Executive Mansion clutch regarding this celestial interloper? White House Deputy Chief of Staff Stephen Miller parried in a shutdown symposium, his retorts meandering through macroeconomic meadows without grazing the object's orbit. Avi Loeb chronicled the evasion in his dispatches, underscoring the void where candor should blaze. The scholarly vanguard teetered on a precipice of paradox petabytes, of payload slumbered in silicon crypts and archival vaults, yet shackled by absent conduits for communal communion skeletal crews, for curation, and evaporated exchequers for execution. And therein bloomed the conspiracy's verdant thicket. Digital bazaars ignited in a frenzy of conjecture. NASA harbors the forbidden essence of 3i Atlas guardians sworn to secrecy. The fiscal furlough, a Machiavellian maneuver to muzzle the revelation. High-rise. Heirlooms unveil the inconceivable, a paradigm-shattering specter that would rend the veil of our cosmic complacency, and they dare not unleash it upon the masses. These fevered fables proliferated like viral nebulae, turbocharged by the uncanny choreography of chronology. The labyrinthine lags unexplained NASA's curated colloquies, anointing the anomaly as banal, bereft of bulwarks of proof. Loeb, wielding his signature scalpel of candor, eviscerated the cabal calculus with dispatch. The lag in liberating the ledger, not a semaphore of stellar sentience, he proclaimed, but a testament to terrestrial torpor. Colossus collaborations demand deliberation. Administrative apparatuses amble at a glacial gait. The budgetary blackout was bona fide, not a fabricated fog. Blunders and misfortune, he posited, eclipse cabals in commonplace cadence. Yet even Loeb conceded the gnawing gall we crave that chronicle. We hunger for those holograms. And with each dawdling dawn, the edifice of empirical esteem crumbles, ceding the chronicle to conjecture's clamor over fact's firmament. Then dawned the Perseverance vignettes. On October 4th at 21:33:39 Martian mean solar meridian, NASA's Perseverance rover perched sentinel in Jezero crater's rust-red embrace snapped a frame via its Dexter navigation optic. The tableau unfurled an attenuated filament slashing the ebony Martian firmament, a luminous lash against the abyss. Astrophotographer Simeon Schmaus orchestrated a mosaic from 20 Mastcam Z exposures and unearthed a spectral smear precisely where 3I Atlas ought to haunt the heavens. He broadcast his bounty across the ether. This, the chorus cried, is 3I Atlas immortalized from the crimson world's crust. Behold the contour, scrutinize the stretch. No amorphous orb. This is a prism, a protracted pillar. Precisely the silhouette you'd summon if this enigma pulsed with artifice. Loeb countered with the velocity of verity. The filament, a figment of the lens. The navcam's acuity clocks, 0.33 degrees per pixel ballooning to roughly 12,500 kilometers at 3I Atlas's remove. The spurious streak sprawled some 50,000 kilometers, gauged by its raster reach. Yet Spherex's stringent scrutiny caps the entity's girth at 46 kilometers, presuming a pallid albedo of 4%. The streak eclipses the quarry by a millennium in length. What manifests Loeb surmised is the smear of swiftness. The optics a cruel epoch entwined with the intruder's arc across the Martian vault forges this illusion of extension. Were 3I Atlas verily a 50,000-kilometer Leviathan, Hubble's gaze would have unraveled it as in sprawled silhouette moons prior it demurred. The streak, then, is a mirage of motion, not a monument to a cylindrical colossus. Yet NASA remained mute, offering no official nod to this truth. The agency hoisted the image onto its multimedia altar as the image of the week for week 252, bereft of a caption to decode its essence, no whisper that this could be Phobos Mars's scarred moon masquerading as 3I Atlas. No forensic dissection of why the streak stretches like a cosmic lance. Just the raw, unadorned frame abandoned to the public's fervent imagination, and the masses wove their tale precisely as you'd foresee. This is the smoking gun. NASA captured an alien juggernaut and is cloaking it in plain view. The agency's silence spun its own saga. Why unfurl an ambiguous snapshot sans context amid a fiscal blackout? Why murmur to media about mundane cometry antics while dangling an image that screams anomaly to untrained eyes? Why hoard the high-rise data that could banish all doubt, letting speculation spiral into a tempest? If NASA's aim was to cradle public trust and scientific sanctity, these choices seem sculpted to sabotage both. Through it all, 3I Atlas pressed onward, a celestial pilgrim unfazed. It glided through the observation window, grazed Mars, and surged toward perihelion. Now it lurks behind the sun, veiled untouchable during the precise epoch when its deeds matter most. It won't resurface until November. When it does, we'll scour for shifts, a tweaked trajectory, a fractured form, or newborn fragments absent before. But without the Mars flyby's foundational glyphs, those elusive high-rise frames will fumble to discern what's novel from what we simply overlooked. Loeb noted that the Mars rendezvous wasn't NASA's exclusive vigil. China's Tianwen-1, the UAE's Hope orbiter with its Emirates Mars mission arsenal, and ESA's twin orbiters all harvested data. ESA has let slivers of their bounty trickle forth. But the sharpest revelations, the ones that could redefine the enigma, remain entombed behind governmental gridlock, bureaucratic molasses, and processing timelines that stretch credulity thinner with each passing week. Zlatnik's playbook unfolds in vivid hues, delay the data, steer the story, frame the verdict, before the raw truth surfaces. If you're feeling charitable, chalk it up to bumbling, not scheming. The outcome, though, is identical. We remain ignorant of 3I Atlas's intimate visage. Its true scale eludes us. Are its chemical signatures as alien as they seem? Or is there a mundane explanation we've yet to entertain? We won't know until NASA deems us worthy of the truth. On August 2nd, 2025, the 2-meter twin telescope at Tide Observatory in the Canary Islands captured an impossibility. Across 159 exposures, each a 50-second pulse of light stacked and honed to unveil details too faint for fleeting glances. 3-hour Atlas emerged with a jet stretching some 6,000 kilometers from its core. But this wasn't the familiar comet tail swept back by solar fury. This jet stabbed toward the sun an anti-tail, a cosmic heresy branded in colloquial terms as impossible. Comet tails bow to the sun's wrath. Radiation and charged particle torrents blast dust grains freed as surface ices vaporize away from the star. Gas molecules ionized by ultraviolet fury are herded backward by the solar wind's gale. Everything flees the sun's embrace. That's the law of tails. That's the bedrock of physics. A sunward tail defies the cosmic current akin to rivers climbing peaks or smoke plunging earthward. It flouts the primal mechanics dictating matter's dance in the void. Yet, it's not entirely without precedent. Anti-tails, rare apparitions, emerge under precise geometric alignments, typically when Earth's gaze slices edge-on through a comet's orbital plane, revealing a thin veneer of debris trailing in its wake. This creates the illusion of a forward-thrusting tail, not matter surging sunward, but a trick of perspective. Except 3I Atlas defies this script. Its viewing angle, a mere 10 degrallen from the sun's line, dismantles the optical sleight. The 2-meter twin telescope's capture reveals a jet when corrected for this angle, stretching tenfold, longer than wide, a lance of matter, not a mirage. Avi Loeb and Eric Cato, in a piercing analysis, dismantled the illusion hypothesis. This is no artifact of geometry, they declared, but a tangible stream of material erupting sunward from 3I Atlas itself, a directed jet. This revelation births two questions that linger like uninvited specters. What force could conjure such a defiant outflow? And why do comet scholars brand this normal, while grasping for explanations that crumble under scrutiny? Hubble glimpsed this anomaly on July 21st at 365 million kilometers remove. Its frame captured a glow stretching ahead of 3I Atlas, pointing brazenly toward the sun. Scientists pounced, heralding a tale proclaiming cometary orthodoxy. Yet their zeal overlooked a fatal flaw. The glow defied the physics of tails. Correct the geometry, and it's no tail, it's a sunward jet. Such jets aren't wholly mythical. Comet C 2014 UN 271, dubbed Bernardinelli-Bernstein, flashed a similar sunward shimmer when spied far from Sol's grasp. The theory, massive dust grains ejected leisurely from the sunlit face, too hefty to be swept back by radiation's push drift forward with the comet before dispersing. Slow ejections, bulky particles, negligible forces, a dust fan masquerading as a sunward tail from certain vantages. Could this cloak 3I Atlas, perhaps? But cracks riddled the fit. First, 3I Atlas spins every 16 hours. A jet from a localized hotspot on its rotating nucleus should flicker pulsing as the hotspot twirls in and out of sunlight every 8 hours. Yet Spherex observations paint a plume stretching 348,000 kilometers, steadfast and unyielding. A hotspot pinned to a pole perpetually sunlit could explain this, but demands an exquisitely precise spin-axis alignment. Improbable, though not impossible. Second, the chemistry jars. Webb telescope data from August 6th reveals a plume steeped in carbon dioxide with scant water and carbon monoxide. CO2 sublimes at lower temperatures than water sparking outgassing farther from the sun. Yet 3I Atlas was already ablaze at 4.0 astronomical units, unusually distant for such vigorous CO2 venting. If this were merely ponderous dust drifting forward, why the skewed chemical signature? Why so much CO2, so little water against the grain of every comet we've charted? Third, the jet's form betrays intent. Both Hubble and the 2-meter telescope capture a feature stretched 10 times longer than wide a columnated spear, not a diffuse haze of dawdling dust. Jets spring from vents or fissures in a nucleus gas and dust erupting in tight streams. A narrow vent on a spinning core should weave a spiral as it rotates. Yet here, the outflow is straighter, steadier, a relentless surge from a fixed bearing. Piece this mosaic together, and the image warps beyond convention, a sunward jet unwavering across weeks, sharply columnated with a 10:1 ratio dominated by CO2 in a configuration that scoffs at passive dust drift. Loeb and Cato brand it anomalous, a cosmic riddle that refuses to bow to the familiar. This demands more than a shrug and a quip about comets' quirks. Jason Wright, an astronomer at Penn State, fired back fiercely against such dismissals. In a blistering blog post, he argued that Loeb and Cato aren't trailblazers in spotting this sunward anomaly. Other teams like Varnum's have charted similar waters, attributing 3I Atlas's forward glow to sluggish ejections of hefty dust grains from its sunlit face. Wright accuses Loeb of gilding a mildly peculiar feature as a revolutionary beacon of artifice, inflating its uniqueness where precedent exists. Wright also zeroes in on the rotation conundrum. With 3I Atlas spinning every 16 hours, its dust plumes stretching hundreds of thousands of kilometers, can't stem from a fixed hotspot. A stationary vent would whip up mechanical chaos torques, shifting outflow patterns, telltale wobbles. We're not seeing those clearly or at all. He points to Oumuamua's erratic tumbling, hinting at complex spins. If 3I Atlas mirrors such dynamics, modeling its dust with a simplistic single-vent assumption is a fool's errand. So who holds the truth? Is this sunward jet a cosmic outlier screaming for exotic answers, or a quirky but natural trait? Loeb's hyping for headlines. The maddening reality we lack the data to settle the score. What's clear is this 3I Atlas boasts a sunward feature etched in Hubble's gaze, the 2-meter twin telescope's frames and Keck's spectroscopic scrutiny. Its sharply columnated 10:1 in length-to-width ratio, steeped in carbon dioxide and steadfast across weeks despite the nucleus's 16-hour whirl. Conventional theories, bulky dust-precise spin-axis alignment, leisurely ejections can theoretically stitch it together. But they demand a delicate alignment of stars, a spin-axis tilted, just so a composition skewed just right, a cascade of low odds factors converging in unison. When you pile improbable on improbable, it starts to feel like forcing the data to kneel to a favored narrative. Here's the kicker true. Anti-tails, fleeting geometric flukes, flicker for days or weeks as Earth crosses a comet's orbital plane. Yet 3I Atlas's sunward spear endured from July through September, a months-long defiance of optical trickery. This is real matter anchored ahead of the nucleus, thrusting toward the sun. And real matter demands a real mechanism to hold it there. One possibility, whispered only in shadows, is thrust. If 3I Atlas vents material from its sun-facing flank, it could act like a rocket gas, jetting one way, nudging the object the other. For typical comets, such thrust is feeble, chaotic waxing and waning as the nucleus spins through light and shadow. But if the venting is focused, say from a region locked sunward, the thrust could be steady, deliberate. Observationally, such a force could masquerade as a propulsion system. Loeb treads lightly, never crying artificial outright. He speaks in measured tones. Warrant's investigation cannot be ruled out. On his scale, 0 for natural, 10 for artificial, 3I Atlas scores a 4. Anomalous, yes. Conclusive, no. It's a puzzle piece that doesn't snap neatly into our cometary canon, yet not so alien as to torch natural explanations entirely. Not yet. The sunward jet is one thread in a broader tapestry. Alone, you could wave it off odd geometry, strange chemistry, uncanny timing, all within nature's reach, if you're willing to swallow a string of unlikely coincidences. But it's not alone. It's one of 8 anomalies, each tugging at the seams of what we believe possible. And when anomalies cascade like dominoes, coincidence layered upon coincidence, the natural explanation begins to creak under its own weight. It morphs into something strained, a desperate grasp at familiarity, a refusal to peer into the abyss where the unthinkable stirs. On August 27th, the Gemini South Telescope pierced the veil, unveiling a conventional anti-solar tail, a faint teardrop silhouette trailing away from the sun as physics decrees. This was hailed as vindication proof that 3I Atlas bends to cometary norms after all. Behold, a proper tale at last. But the chronology whispers heresy. For months, only the sunward jet had mocked convention. Then, as Sol's heat intensified, drawing the object nearer, this orthodox tale materialized not as a replacement, but a companion. The defiant jet endured, now flanked by its backward-pointing kin. Both in tandem, one lunging toward the blaze, the other fleeing in terror. If this symphony of contradictions is mere eccentricity, a comet's caprice, then why the protracted silence from the expected tale? Why did the aberrant jet blaze, first unyielding even as its counterpart bloomed? These riddles linger unanswered, gnawing at the edges of certainty. They compel a double take, a lingering gaze into the void, stirring the suspicion that we're beholding the unprecedented, not because it's impossible, but because it defies the very blueprint of existence. A comet crowned with a tail sprouting from its brow, as Loeb quipped with vivid flair. An enigma hell-bent on fracturing norms, just enough to unsettle the soul, yet coyly short of shattering the paradigm outright. And amid the fray, that persistent thorn, if this is truly mundane, why the labyrinth of justifications? Why the flurry of papers, the dueling doctrines, the meticulous dissections of geometry, and spin the frantic appeals to improbable alignments of axes and grains? Ordinariness doesn't demand such Herculean contortions to conform. It simply is. On August 24th, 2025, the Keck 2 telescope in Hawaii swiveled its cosmic web imager toward 3I Atlas, unleashing a spectral storm that would rewrite the annals of astronomy. The data, immortalized in a paper by W.B. Hugendam and colleagues, unveiled a phantom never glimpsed in any natural wanderer of the stars. The gas plume encircling 3I Atlas pulses with vivid emission lines from neutral nickel atoms, bold, crystalline, undeniable. And yet, no iron shadows its glow. In every comet chronicled before, from our solar system's humblest vagabonds to the interstellar ghost of 2I Borisov nickel and iron stride as inseparable twins locked in ratios as steadfast as the tides. They forge together in the crucibles of ancient minerals within cometary hearts, vaporizing in tandem as solar fire licks the surface, their signatures entwined eternally in the spectra until this moment. Keck's revelations eclipse the norm by orders of magnitude. Nickel surges, not in modest excess, not doubled or tripled, but amplified exponentially beyond the median of solar system comets. And the iron vanished. Not diminished, not a whisper utterly absent. This isn't whimsy of composition, nor the gentle variance of nature's palette. This is a chemical clarion that echoes nowhere in the wilds of the cosmos. The paper declares it outright the nickel to cyanide production rate dwarfs that of 2I Borisov and towers magnitudes above the solar system's cometary baseline. Nickel untethered from iron in such profusion finds but one earthly echo, the forge of human ingenuity, industrial nickel refinement via the carbonyl pathway. Let us confront this squarely without flinching. Nickel tetracarbonyl chemical incantation. NiCO4 is no cosmic relic, but a cornerstone of mortal alchemy. In the Mond process, our contrivance for distilling nickel's essence impure ore encounters carbon monoxide at tempered warmth. Nickel alone yields to the gas, birthing the volatile carbonyl vapor, sloughing impurities like shed skin. This ethereal compound is then coaxed to rupture under heat, precipitating pristine nickel and exhaling its monoxide progenitor. This cycle formation, isolation, decomposition is humanity's signature, a technological rite demanding exacting temperatures, sealed atmospheres, and engineered precision. Nature, in her boundless sprawl, spurns such choreography. She conjures no sustained ballet of conditions to birth it reliably. Yet here, etched in starlight from an exile beyond our stars, we trace nickel emissions mirroring carbonyl's decay, pristine iron-scarred absent, as if refined in some distant forge. The paper confronts this spectre beyond 3I Atlas. Nickel sans iron haunts only are wrought alloys, not the comas of comets, the husks of asteroids, the whispers of interplanetary dust. Nowhere in the untamed void, save now in this stellar trespasser from alien skies. The instinctive recoil surges like reflex. This cannot herald what it seems. Surely some arcane alchemy eludes us, an exotic brew on 3I Atlas's flank that apes our refineries by sheer caprice. And perhaps that's the truth, a serendipitous mimicry in the cosmic theater. But what alchemy could birth, nickel vapor untethered from iron in the wilds of space? The Very Large Telescope team, wielding the UVES spectrograph, tackled this head-on. At the frigid distances where comets roam, temperatures plummet far below the thresholds needed to vaporize silicate sulfides or metallic grains harboring nickel and iron. Thus, the presence of these metals in a comet's coma is a cosmic conundrum. They note that 3I Atlas, a C2 depleted comet lacking the usual diatomic carbon molecules, exhibits extreme traits early in its activity, with nickel production rates and nickel-to-iron ratios that defy all precedent. This chemical cocktail, devoid of iron and steeped in nickel, paints a profile alien to any natural body catalogued. The VLT team stopped short of whispering artificial. They catalogued the anomaly with surgical precision and let it hang a spectre unspoken yet inescapable. If this is nature's handiwork, it demands mechanisms beyond our grasp. And if those mechanisms elude us, how can we proclaim their naturalness with conviction? Keck's narrowband images deepen the mystery, isolating cyanide and nickel emissions. Both stretch asymmetrically, fanning toward and away from the sun, with nickel mirroring cyanide's pattern, but dwarfing it in ratio far beyond Borisov or any solar system comet. The white light image, tracing dust-scattered sunlight, betrays no classic cometary tale. Instead of a tidy backflow, driven by solar radiation, the dust scatters in chaotic directions, as if unleashed without deference to the sun's push. Cyanogen CN is no stranger to comets born when ultraviolet rays shatter complex organics on the surface. But the nickel-to-cyanide ratio in 3I Atlas is a jarring outlier, hinting at an alien process vaporizing its surface. Typical sublimation yields predictable ratios. Here, the scales tip wildly, suggesting something other than cometary norms at play. Loeb seizes this as a linchpin, pointing to nickel tetracarbonyl NiCO4, a compound forged in the Mond process, humanity's method for refining nickel. This process isolates nickel from iron, yielding a pure metal source. The absence of iron in 3I Atlas's emissions suggests a refined origin, not the mixed mineral grains typical of comets. Critics cry foul, accusing Loeb of cherry-picking. Yes, the ratios are bizarre, the composition uncanny, but leaping to industrial refining, let alone alien craftsmanship, spans gulfs of uncertainty. Natural processes, temperature gradients, selective melting differentiation in the parent body, or preferential vaporization could, in theory, sculpt this anomaly. With only 3 interstellar objects studied and detailed spectra from 2, our cosmic sample size is laughably thin. Declaring 3I Atlas artificial based on a handful of solar system comets is reckless, they argue. Yet the counterpoint cuts deeper. Science thrives on anomalies. When patterns fracture, we face 3 paths: expand our models, gather more data, or ignore the discord. The astronomical community wavers between expansion and dismissal, with scant zeal for pursuit. Expanding our models demands new geochemical recipes to conjure nickel sans iron in cometary voids. Fine propose them, test them, show why these conditions bless an interstellar wanderer, but spurn our local comets. So far, no one has. Papers label the anomaly puzzling and pivot away, offering no robust natural scaffold. That's not science embracing the unknown. It's science sidestepping it. More data is the clarion call. We need spectra across wavelengths, tracking emission shifts as 3I Atlas dances closer to then away from the sun. JUICE is slated to probe it in November Juno in March 2026 near Jupiter. These could crack the enigma. Until then, we grapple with a chemical signature whispering of industry nickel at 4 grams per second iron absent, nickel to cyanide ratios soaring orders of magnitude beyond peers, echoing nickel carbonyl's decay. Ignoring it, the favored tack sees astronomers crown 3I Atlas a comet and shut the book. Anomalies, mere quirks destined for tidy explanations as our grasp of comets grows. This is motivated reasoning, starting with natural and bending data to fit. When the fit falters, Elaborate scenarios multiply to prop up the verdict. If Mars returned a sample with these signatures, nickel sands iron carbonyl echoes, we'd debate contamination or radical geochemistry. Not shrug Mars is weird. Yet 3I Atlas, distant and fleeting, invites dismissal. Its oddity is chalked up to the cosmos's vastness, a placeholder for future clarity. Perhaps it's just that a weird thing soon to make sense. Or perhaps we're staring at a genuine anomaly, a fracture in our natural canon, demanding either a bold rewrite or a reckoning with ideas long banished to the fringes. The nickel, the carbonyl signature, the industrial echo. These don't prove artifice, but they scream for scrutiny beyond rote assumptions. Keck's data lies open for any telescope to verify. The question isn't just what 3I Atlas is, it's whether we dare follow where its evidence leads. The question burns will. Anyone wield the tools to probe 3I Atlas with an unclouded lens open to every possibility? Or have we already crowned it a comet and tasked the data with catching up to our verdict? The measurements beckon accessible to any with the gear and grit to chase them. Yet the deeper challenge lies not in the instruments, but in the mindset, whether we dare to question the comfortable or cling to the ordained. The improbable path, interstellar space, is a boundless expanse, a three-dimensional void where wanderers from distant stars can pierce our solar system from any angle, plunging from above, slicing from below, or carving sideways through the cosmic tapestry. The ecliptic plane, the slender disk where Earth, Mars, Venus, Jupiter, and their kin waltz around the sun, is a mere whisper of possibility amid this vast sphere of approach vectors. Random interstellar interlopers should by all odds skewer our system at steep inclines, soaring far above or diving well below this planetary platter. A few might graze closer to the ecliptic by chance, but the odds of one threading the needle within a hair's breadth of this plane, say 5 degrees, are vanishingly slim. Enter 3I Atlas, gliding within 4.89 of the ecliptic, a trajectory so flat it's practically defiant. Avi Loeb crunched the numbers. The solid angle of a 5-degree cone around the ecliptic, divided by the full sphere of possible paths, yields a probability of roughly 0.2%, 1 in 500. Not impossible, but a cosmic long shot. Rare events happen, sure. Observe 500 interstellar visitors, and one might statistically flirt this close to the plane. But here's the rub: we've catalogued only 3 such travelers: Mai, Oumuamua, 2I, Borisov, and 3I Atlas. Oumuamua angled in at a steep 26 degrees, Borisov at a sharper 44 degrees, both as expected for random cosmic drifters. Yet 3I Atlas, the third, nails the statistical outlier, hugging the planetary plane with uncanny precision. Unlikely, yes. Impossible, no. But the plot thickens. This object doesn't merely skate the ecliptic, it moves retrograde counter to the planet's flow. Not inherently odd. Interstellar objects can arrive from any bearing. What's striking is the timing. 3I Atlas arrived poised to thread past Mars, Venus, and Jupiter in a tight temporal window, each encounter within tens of millions of kilometers. It grazed Mars at 30 million kilometers on October 3rd, with Venus and Jupiter slated for similar proximities in the months ahead. These close brushes aren't random. They're woven into the orbital mechanics of a retrograde path, aligned flat, arriving at this precise cosmic moment. Loeb's calculations peg the odds of this choreography flat trajectory plus pinpoint timing for multiple planetary flybys at 0.005%, or 1 in 20,000. Stack these odds: 1 in 500 for the flat path, 1 in 20,000 for the planetary dance. Combined, we're wading into 1 in 10 million territory. But the improbabilities don't end there. 3I Atlas's arrival vector aligns within 9 degrees of the fabled WOW signal, that enigmatic 72-second radio burst caught by the Big Ear telescope in 1977, scrolled with WOW by astronomer Jerry Amon. Hailing from Sagittarius near Scorpius, it vanished despite relentless searches, its origins a cosmic cipher. 3I Atlas emerges from the same celestial neighborhood, a mere 9 degrees apart, a sliver in galactic terms. The odds of an interstellar object homing in from within 9 degrees of a random sky patch, about 0.6% or 1 in 167. Now, we're juggling 3 rarities: a 1 in 500 trajectory, a 1 in 20,000 planetary waltz, a 1 in 167 alignment with the WOW signal. Even factoring correlations, the flat path enabling the flybys, the combined probability plunges below 1 in a million. When does coincidence cease to suffice? When do we concede that chance strains under the weight of such a pattern? Loeb argues we've crossed the threshold, ranking 3 Atlas a 4 on his scale. Genuinely anomalous, not conclusive, because its trajectory, chemistry, and physics weave a tapestry that frays belief in accidental convergence. Critics counter with selection bias. We spotlight the peculiar because it dazzles. Countless unremarkable interstellar objects likely slip through undetected, too dim, too swift, or ill-timed for our gaze. If thousands pass yearly, as models suggest, catching one with an odd path isn't shocking, it's inevitable. The surprise is merely that 3I Atlas glowed bright enough to study, fair but limited. Detection bias might explain a single quirk, a flat trajectory perhaps. But it buckles under the burden of multiple anomalies converging in one object: the ecliptic hug, the planetary rendezvous, the WOW signal echo, the sunward jet, the nickel deluge, the anomalous mass, and Serida's Fibonacci alignments. When one object hoards such a litany of rarities, you wonder, is this bias at work? Or is 3I Atlas whispering something extraordinary? If 3I Atlas were a probe engineered to scrutinize the inner solar system, its trajectory would be a masterclass in efficiency. You'd choose a path skimming the ecliptic plane to weave through the planetary parade Earth, Mars, Venus, Jupiter, without squandering energy to chase them. A retrograde orbit would be ideal, letting the planet's own motions usher them toward you, stacking close encounters like pearls on a string. Timing would be critical, arriving precisely to glide past Mars, graze Venus's orbit, and swing by Jupiter in a tight temporal window, leveraging ballistic arcs and gravity assists to let the sun's pull do the heavy lifting. 3I Atlas's path flat at 4.89 degrees to the ecliptic retrograde, and time to pass within 30 million kilometers of Mars on October 3rd, with Venus and Jupiter queued up mirrors this blueprint. It's not flawless. It doesn't kiss Earth's doorstep, for instance. But its efficiency is uncanny, far sharper than a random cosmic toss would yield. With odds of such a trajectory, 1 in 500 for the flatness, 1 in $20,000 for the planetary choreography, stacking into a 1 in 10 million rarity, the question looms: is this the signature of design, a calculated course to maximize data while minimizing fuel? Or is it the luckiest fluke in interstellar annals? The speculation sharpens as 3I Atlas hits solar conjunction. Yesterday, October 20th, 2025, vanishing behind the sun's glare. It's now barreling toward perihelion on October 29th, 8 days hence the point of closest solar approach, where gravitational potential dips lowest and propulsive maneuvers gain maximum leverage via the Oberth effect. for her spacecraft. This is the moment to fire engines, tweaking velocity or direction with minimal energy. If 3I Atlas is a comet, we'd expect only heightened outgassing as solar heat bites. But if it harbors propulsion, artificial deliberate perihelion is the stage for action, and it's hidden. Earth's telescopes are blind, unable to monitor. Come early November, when 3I Atlas emerges, we'll plot its position against gravitational predictions. If they align, it's business as usual. A mismatch, however, signals force applied during its solar eclipse non-gravitational acceleration. Outgassing can cause this, yes, but Loeb's analysis of data from May 15th to September 23rd, 2025 shows no such drift despite 150 kiloSCH of CO2 venting at 440 METS. That's thrust momentum bleeding from the nucleus. Yet the path held steady, implying a mass so colossal that the force barely nudges it. If acceleration suddenly spikes post-perihelion after months of inertia, that's a red flag demanding answers. Another possibility: fragmentation. Comets can crack under solar stress, thermal shock rotation, or tidal strain, splintering into shards. If 3I Atlas is natural, we might see such a breakup. But if it's a mothership, as some dare whisper, releasing probes, would mimic fragmentation, except the pieces wouldn't scatter aimlessly. They'd fan out with intent, each carving a path to distinct targets. Distinguishing random rubble from purposeful probes would demand meticulous tracking of their trajectories over weeks. Loeb posits that probes ejected at perihelion with 30-40 km could harness the Oberth effect to reach Earth by late December or early January, eerily aligning with Serida's Christmas Day prophecy, though rooted in orbital mechanics, not Fibonacci mysticism or Fatima Lore, coincidence or convergence. When disparate lenses, Loeb's physics, Serida's numerology point to late December, it's either a cosmic pattern crystallizing or a collective delusion weaving similar threads. The next 70 days will decide. Right now, 3I Atlas basks in peak solar energy, cloaked from view. If something is to stir, this is the hour. And we're blind, left to await its November unveiling to see if the universe has another shock in store. When a comet vents gas and dust, physics enforces atoll action, demands reaction. Escaping material carries momentum, pushing the nucleus oppositely like a balloon careening as air flees. This non-gravitational acceleration, subtle in large comets, nudges them off gravity's script over time. Measure the position, compare it to gravitational predictions, and the gap reveals the thrust's strength. Loeb scrutinized 3I Atlas's orbit from May 15th to September 23rd, 2025, 4.5 months of tracking. Webb telescope data confirmed CO2 sublimating at 150 kZ with an outflow velocity of 440 ms, substantial mass loss, undeniable momentum. Thrust should have shifted its path. Yet the observed positions hugged gravitational forecasts within error margins. No detectable drift. This defies expectation. Thrust is inevitable. Conservation of momentum doesn't bend. So why the steadfast trajectory? Only one answer holds. The object's mass is so immense that the thrust, real measurable, yields acceleration too minor to detect. Force equals mass times acceleration, and a titanic mass shrinks acceleration to insignificance, leaving 3I Atlas an unyielding behemoth against the push of its own exhalations. Acceleration is force divided by mass. A colossal mass shrinks acceleration to a whisper undetectable if the mass is vast enough. Avi Loeb ran the numbers an upper limit of 0.028 arcseconds. Positional deviation over 4.5 months translates to a maximum acceleration. Pair that with the known thrust 150 kilojoules of CO2 venting at 440 ms, yielding 66,000 newtons of force. Divide force by acceleration, and you get a minimum mass 33 billion tons. That's the floor. 3I Atlas must weigh at least this, or we'd have seen it veer from its gravitational path. Picture this: at a typical cometary density of 600 kilolus M3R, a 33 billion ton sphere spans roughly 5 kilometers about Manhattan's width. Compare that to 1I Oumuamua, 100-200 meters, or 2I Borisov, 1 kilometer. 3I Atlas is 1,000,000 times more massive than Oumuamua, 1,000 times heavier than Borisov, and moving faster. Interstellar objects follow a power law. Small ones are legion giants scarce. A 5-kilometer object reflects 25 times more sunlight than a 1-kilometer one, making it easier to spot. But rarity still rules. Small objects dominate, so finding a behemoth like 3I Atlas as only our third interstellar catch is statistically jarring. Loeb argues this mass, 33 billion tons, minimum marks 3I Atlas as an outlier. Either the interstellar population brims with more giants than models predict, or 3I Atlas isn't a random draw. Is it a deliberate envoy, a relic from primordial planet formation, a shard of a shattered titan? Each theory demands contortions. High-rise images could settle it. At 30 kilometers pixel during the Mars flyby, a saturated pixel signals a nucleus at least 30 kilometers wide, far beyond the 5-kilometer minimum, pushing natural origins to the brink. A dimmer pixel or multi-pixel spread could pinpoint size via brightness and albedo. But those images remain locked away. Spherex offers another clue. In August, it clocked 3I on Atlas's brightness, capping its diameter at 46 kilometers, so assuming 4% albedo. Beyond that, it would outshine observations, so the size ranges from 5-kilometer mass derived to 46 kilo brightness limited. Even 5 kilometers is anomalous. 46 kilometers is ludicrous. Objects that large aren't comets. They're dwarf planets sculpted by internal evolution differentiation, perhaps even melting. Such giants shouldn't roam interstellar space at hyperbolic speeds. Ejection mechanics favor the small. Planets sling kilometer-scale comets into the void with ease, but hurling a 5-kilometer object demands more energy. A 46-kilometer Titan requires a cataclysmic nudge. Large objects are more likely to be perturbed, shattered, or captured than cleanly ejected. Finding one intact hurtling through is a cosmic unicorn. If high-rise confirms a nucleus nearing tens of kilometers, natural explanations teeter. Combine that with the 1 in 10 million trajectory nickel-heavy chemistry and sunward jet, and the artificial hypothesis demands a seat at the table not as gospel, but as a contender worth probing. This mass also anchors the sunward jet's stability. A 33 billion ton colossus shrugs off the jet's thrust. The 66,000 newtons barely perturb it, allowing a steady columnated jet to persist for weeks without tumbling or complex rotation. Lighter objects would wobble under such asymmetric force, but 3I Atlas spins serenely every 16 hours, like a monolithic body under minimal torque. This stability aligns with immense mass, but massive interstellar objects, especially ones threading improbable paths with alien chemistry, aren't just rare. They're supposed to be impossible. The data screams anomaly, peer-reviewed, measured, undeniable. The 33 billion ton minimum mass isn't conjecture. It's math-rooted in Webb's confirmed outgassing 150 kilogravitors at 440 MASS and the absence of non-gravitational drift from May to September 2025. The calculations are public replicable by anyone with a calculator and the data. Either 3I Atlas is at least 5 kilometers wide and staggeringly massive, or multiple observatories Webb Spherex Keck suffered synchronized errors. That's a stretch. So we grapple with the reality 3I Atlas is a titan dwarfing 1I Oumuamua 100-200 met and 2I Borisov 1 kilomet by factors of 1,000,000 and 1,000 respectively. If it's a comet, it's the largest interstellar one ever seen by a chasm. If it's not, we're staring at a new breed of object, massive enough to shrug off outgassing thrust, potentially housing internal complexity compartments, systems, instruments. This veers into speculative realms, interstellar probes, generation ships, eons-long explorers. But the data, not fiction, drags us there. A 5 to 46 kilometer shell could, in theory, encase such marvels. Dismissing this because it echoes sci-fi, ignores a truth fiction, often precedes reality we haven't met. High-rise images are the linchpin. At 30 kilometers per pixel, they'd reveal the nucleus's size-saturated pixel for 30+ kilometer dimmer, for smaller multi-pixel for precision. Without them, we're tethered to indirect bounds, 33 billion tons, 5 kilometer minimum from mass, 46 kilometer maximum from Spherex's brightness, 4% albedo. Even 5 kilometers is a statistical shock. 46 kilometers is a cosmic absurdity, not comet, but dwarf planet evolved and differentiated. Such giants shouldn't roam interstellar highways at hyperbolic speeds. Yet here one sits. Today, October 21st, 2025, 3I Atlas is at solar conjunction, veiled behind the sun's glare, unobservable by ground or space telescopes. Perihelion looms on October 29th, 14 AU from the sun, where solar intensity peaks pumping 33 gigawatts, equivalent to 33 nuclear plants, into a 5 kilometer object. For a comet, this fuels peak outgassing. For something artificial, it could power systems, charge reserves, or drive maneuvers. The Oberth effect makes perihelion the prime moment for course changes. A small thrust here yields massive orbital shifts. Spacecraft designers exploit this Apollo planetary flybys. All time burns at gravity's deepest. If 3I Atlas is engineered, it could act now, and we're blind to it. When it emerges in November, we'll compare its path to gravitational predictions. Alignment means nothing shifted. Deviation signals force outgassing perhaps, but sudden acceleration after months of inertia, despite 66,000 newtons of thrust, would defy Loeb's mass calculations. Fragmentation is another possibility. Comets crack under solar stress, spawning slow-drifting shards, meters as hoishes. But deliberate probe release would look different, objects splitting at hundreds of meters s, fanning toward targets like Mars, Earth, or Venus. Loeb suggests 30 to 40 kilometers ejections at perihelion could send probes to Earth by late December, aligning with Serida's Christmas Day prediction despite their divergent logic orbital mechanics versus mystical numerology. This convergence, December 25th to early January chills. Coincidence or a pattern too sharp to ignore? If probes target Earth, we'd have weeks to track their vectors, but confirmation might come too late. We lack defenses against hypersonic cosmic objects, protocols for alien contact, or frameworks for such realities. This is black swan territory, an outlier mass trajectory chemistry, with extreme impact redefining existence, rationalized only in hindsight. Nassim Taleb's concept fits history bends to rare seismic shocks. We expected small, dull interstellar objects. 3 in 8 years, culminating in 3I Atlas's anomalies, upends that. The trajectory alone 1 in 10 million odds for its flat retrograde planet-hopping path suggests intent. Add the nickel-heavy, iron-free emissions the sun would jet and a Manhattan-sized mass, and the natural label phrase. if HiRISE shows a nucleus nearing 46-kilometer natural origins buckle. We're not claiming artifice outright, but the data demands we consider it, not dismiss it as fringe. For now, 3I Atlas lurks behind the sun at peak energy, possibly acting while we wait blind for November's revelation, the third interstellar visitor to grace our solar system. 3I Atlas looms as a cosmic titan, its peculiarities piling high enough to spark a profound question. Are we merely witnessing an eccentric natural object, or is this something engineered, a revelation that could either remain a curious footnote in astronomical annals or rewrite humanity's place in the cosmic order? Avi Loeb, ever the provocateur, has taken this question to the world's stage briefing policymakers, penning letters to the United Nations, gracing news programs, and crafting essays that dissect the object's anomalies with surgical precision. He urges vigilance, not hysteria, but a measured readiness. He calls for a global symphony of observations, a mobilization of resources to track this enigma, to prepare for the slim but seismic possibility that it's more than a comet. The response, however, has been a muted chorus. Scientists, steeped in skepticism, see another overblown anomaly destined to fade into the long history of misidentified phenomena. Policymakers wager it's a false alarm, a fleeting distraction soon to be forgotten. They're likely right statistically, probably. But probably is a flimsy shield when the stakes could upend civilization itself. A 1% chance that 3I Atlas is artificial, or even a 0.1% whisper, demands more than a shrug. The cost of dismissing it and being wrong is cataclysmic humanity caught unprepared for a paradigm-shifting encounter. The cost of investigating and airing a few squandered resources and a fleeting blush of embarrassment. The scales tip starkly. Today, October 21st, 2025, at 09:03 a.m. plus 07 3IE Atlas crouches behind the sun at solar conjunction, veiled in its blinding corona beyond the reach of our telescopes, ground-based or spaceborne. In 8 days, on October 29th, it will hit perihelion, its closest brush with the sun, at 1.4 astronomical units just inside Mars's orbit. Here, solar energy peaks bathing its surface in 33 gigawatts of power for a 5-kilometer object equivalent to 33 nuclear power plants running full tilt. For a comet, this heat would ignite peak outgassing, a frenzy of sublimating ices. For something artificial, it's a golden hour to charge, systems power instruments, or execute maneuvers, leveraging the Oberth effect, where a small thrust at maximum velocity yields outsized orbital shifts. Spacecraft designers live by this principle. Apollo's lunar burns planetary flybys, all time for gravity's deepest wells. If 3I Atlas harbors propulsion, now is when it would act, and we're blind to it, our view blocked by the sun's radiant wall. When it emerges in early November, we'll pin its position against gravitational predictions. If they align, its business as usual. A deviation, however, signals force perhaps outgassing, but a sudden lurch after months of inertia, despite 150 kilod's of CO2 venting at 440 miss 66,000 newtons of thrust, would clash with Loeb's calculations of a 33 billion ton mass. Fragmentation is another possibility. Comets' fragile rubble piles can fracture under solar heat rotation or tidal strain, spawning shards that drift apart at meters per second. But if 3I Atlas were a mothership releasing probes, the pattern would diverge objects splitting at hundreds of meters per second each arcing toward distinct targets: Mars, Earth, Venus, Jupiter. Loeb posits that probes ejected at perihelion with 30 to 40 kilometers ahead could reach Earth by late December or early January, eerily echoing Serida's Christmas Day prophecy, though grounded in orbital mechanics, not mystical numerology. This convergence, two disparate paths pointing to late December chills. Is it coincidence or a pattern too sharp to dismiss? The next 70 days will tell. But now, at the moment of maximum solar energy, 3i Atlas acts unseen, leaving us to wait for November's unveiling, the government shutdown, stalled high-rise images, and NASA's vague, normal comet briefings sans evidence have deepened the fog. These missteps, whether bureaucratic bungling or deliberate obfuscation, leave us grasping for clarity at the most critical juncture. November will test the trajectory. December, any earthbound objects. March 2026, when Juno observes near Jupiter, will add data. But today, as 3i Atlas basks in solar fire, we're left in suspense, wondering if the universe is poised to jolt us awake. Loeb's anomaly scorecard ranks 3i Atlas a 4 out of 10 0 for natural, 10 for artificial. A 4 is a clarion call for scrutiny driven by 8 anomalies, each a crack in the natural facade, together a mosaic of improbability. We've probed 4, the 1 in 10 million trajectory, the sunward jet nickel sans iron, and a 33 billion ton mass. Here are the rest, completing a picture that pushes 3i Atlas into uncharted waters. Light scattering off cometary dust polarizes, revealing particle traits, size, shape, composition. Solar system comets reliably show positive polarization. Light aligned, perpendicular to the scattering plane, a hallmark etched across decades of observation. 3i Atlas defies this flaunting negative polarization light, parallel to the plane, an unprecedented signature unseen in any comet, including 2i Borisov. Data from professional observatories using standard techniques confirm this stark anomaly. Explanations stumble tiny particles. Sub-wavelength would dim the coma, clashing with its brightness. Exotic compositions demand materials alien to solar system dust. Altered geometry requires a dust distribution defying norms stable across multiple observations. Each theory leans on rare conditions, stacking improbability on improbability, leaving the signal unexplained. Anomaly 6. Near-absent water. Comets dubbed dirty snowballs brim with water ice spiced with CO2 and other volatiles. Solar heat sublimates, water birthing comas, and tails with water-dominating spectra. 3i Atlas inverts this script. Web data reveals a plume of 96% CO2, a mere 4% water, opposite the water-rich norm of comets like 2i Borisov. Why so little water? One theory suggests formation far from its parent star, where coal locks water in solids, while CO2 condenses. Eons in interstellar space could see cosmic rays strip hydrogen morphing water into CO2 via radiolysis. But this demands prolonged exposure and selective chemistry hard to reconcile with the extreme 4% water ratio. Natural processes strain to explain this inversion without invoking extraordinary conditions. The third interstellar interloper to breach our solar system, 3i Atlas, stands as a towering enigma, its peculiarities stacking like a cosmic house of cards, each anomaly daring us to question whether it's a natural oddity or a crafted harbinger that could redefine humanity's cosmic narrative. Avi Loeb, ever the relentless provocateur, has carried this question to the global stage briefing policymakers, petitioning the United Nations, gracing newsroom debates and penning essays that dissect its anomalies with forensic clarity. He doesn't preach panic, but pleads for vigilance, a call for synchronized global observations, a readiness to deploy resources, a willingness to brace for the slim but seismic possibility that 3I Atlas is more than a comet. The response, however, is a muted hum. Scientists steeped in skepticism see another overhyped anomaly destined to dissolve into the annals of misread signals. Policymakers wager it's a fleeting distraction, another false alarm in a lineage of cosmic mirages. Statistically, they're probably right, but probably is a fragile bulwark when the stakes could unravel civilization itself. A 1% chance or even a 0.1% whisper, the 3I Atlas is artificial demands more than a dismissive shrug. The cost of ignoring it and being wrong is existential humanity blindsided by a paradigm-shifting event. The cost of investigating and airing a handful of misspent resources and a fleeting blush of embarrassment. The asymmetry is stark, the choice almost self-evident. Today, October 21st, 2025, at 09:05 a.m. plus 07 3I Atlas lurks at solar conjunction, cloaked behind the sun's blinding corona, beyond the reach of Earth's telescopes, ground-based or spaceborne. In 8 days on October 29th, it will reach perihelion, its closest embrace with the sun at 1.4 astronomical units just inside Mars's orbit. Here, solar radiance peaks, flooding its surface with 33 gigawatts of energy for a 5-kilometer object equivalent to 33 nuclear power plants roaring at full capacity. For a comet, this heat would ignite a frenzy of sublimating ices, a peak in outgassing. For something artificial, it's a prime window to charge systems power instruments or execute maneuvers exploiting the Obert effect, where a small thrust at peak velocity yields massive orbital shifts. Spacecraft designers live by this axiom. Apollo's lunar burns, planetary flybys, all timed for gravity's deepest wells. If 3I Atlas harbors propulsion, now is its moment to act, and we're blind, our view blocked by the sun's radiant veil. When it emerges in early November, we'll map its position against gravitational predictions. Alignment signals continuity, deviation betrays force, perhaps outgassing. But a sudden lurch after months of inertia, despite 150 kilojoules of CO2 venting at 440 ms 66,000 newtons of thrust, would clash with Loeb's 33 billion-ton mass calculations. Fragmentation looms as another possibility. Comets, fragile rubble piles, can splinter under solar heat rotation or tidal strain, spawning shards that drift apart at meters per second. But if 3I Atlas were a mothership releasing probes, the pattern would diverge objects splitting at hundreds of meters per second, each arcing toward distinct targets: Mars, Earth, Venus, Jupiter. Loeb posits that probes ejected at perihelion with 30-40 kilometers could reach Earth by late December or early January, aligning with Serida's Christmas Day prophecy, though grounded in orbital mechanics, not mystical numerology. This convergence, two disparate paths converging on late December, chills the spine. Coincidence or a pattern too sharp to dismiss? The next 70 days will decide, but now, as 3I Atlas basks in solar fire, we're left in suspense, unable to witness its potential actions. The government shutdown stalled high-rise images, and NASA's vague normal comet briefings, without substantiating evidence, have deepened the fog, leaving us grasping for clarity at the most pivotal moment. November will test the trajectory. December, any earthbound objects. March 2026, when Juno observes near Jupiter, will add data. But today, As 3i Atlas navigates its unseen climax, we're left waiting blind, uncertain, on the cusp of answers that could either fade into obscurity or ignite a new epoch. Loeb's anomaly scorecard ranks 3i Atlas a 4 out of 10-0 for natural, 10 for artificial. A 4 is a clarion call for scrutiny driven by 8 anomalies each, a fracture in the natural facade, together a mosaic of improbability. We've probed 6, the 1 in 10 million trajectory, the sunward jet nickel sans iron, the 33 billion ton mass extreme negative polarization, and near absent water. Here are the final 2, sealing a case that pushes 3i Atlas into uncharted cosmic territory. Cyanogen CN molecules are cometary staples, born when ultraviolet rays shatter organic compounds in the nucleus. Their abundance relative to other emissions reveals the comet's organic chemistry. 3i Atlas's cyanide emissions are orders of magnitude stronger relative to water than any known comet, and its nickel to cyanide ratio soars equally far beyond norms 2i4 Borisov and solar system comets included. These ratios don't just nudge the boundaries. They vault into a chemical realm no observed object has ever occupied. Cyanide is a biomarker precursor, a building block for amino acids and nucleotides in prebiotic chemistry. High cyanide suggests an organic-rich nucleus, but such richness typically pairs with abundant water, as the chemistry forging organics also births H2O. Yet 3i Atlas defies this flaunting copious cyanide alongside a mere 4% water. It's a cosmic paradox, a lush forest thriving in a bone-dry desert, a chemical profile that mocks known planetary pathways. No natural mechanism cleanly explains this inversion, leaving 3i Atlas as an outlier, demanding new chemistry or something stranger. Here we tread into speculative waters, where Serida's claims ignite both intrigue and skepticism. 3i Atlas's rotation period, measured at 1616 plus 0.01 hours, 969.6 minutes, aligns eerily with Serida's numerological musings, tying to Methuselah's biblical age. 969 years, the golden ratio squared, and Fibonacci sequences allegedly encoded in its orbital relationships. Mainstream astronomers scoff, and perhaps rightly so. Humans are pattern-hungry, seeing faces in clouds, meaning in static. The universe brims with numbers. Dig deep enough, and golden ratios or Fibonacci spirals emerge in chaos, proving nothing of intent. Yet the rotation period is hard data, not conjecture. Serida's math dividing 969.6 minutes by Earth's sidereal period to approximate the golden ratio squared is verifiable. It's a mathematical fact, not a fantasy. Does it mean anything? Likely not. Such patterns litter natural systems like pi popping up in random data. But Serida's October 13th observation, a 5 to 813 Fibonacci pulse sequence, is harder to wave off. If confirmed, this specific repeating pattern isn't just a ratio. It's a signal demanding explanation. If no other observatory saw it, it could be error or misinterpretation. Serida insists the data exists. Without independent verification, it lingers as a tantalizing maybe. These 8 anomalies, trajectory, jet nickel mass polarization, water cyanide, rotation, form a constellation of improbabilities. Each in isolation might stretch natural explanations with caveats. Low probability trajectory 1 in 10 million odd jet geometry, exotic chemistry, a 5 to 46 kilometer behemoth, unprecedented polarization, inverted water ratios, extreme cyanide, and numerological echoes. Each gets a pass if you're generous with assumptions, rare alignments, unknown processes, statistical flukes. But all 8 converging in one object, That's a tower of coincidences too tall to stand without scrutiny. Loeb doesn't proclaim 3I Atlas a spacecraft or alien artifact. He's clear it's a rank for genuinely anomalous, not conclusive. It could be a natural outlier with bizarre traits or something else entirely. The data sits in ambiguous limbo, neither forcing nor ruling out artifice. The 33 billion-ton mass derived from unyielding orbital data, no non-gravitational drift, despite 66,000 newtons of thrust, demands a 5-kilometer minimum diameter, possibly 46-kilometer dwarf planet scale, not cometry. High-rise images could settle this, revealing the nucleus's size. But their absence leaves us with calculations and unease. 3I Atlas, now hidden at perihelion, may be acting shifting course, releasing probes while we're blind. If it emerges off-path or fragmented with purpose, the natural label phrase further. We're not claiming aliens, but the data begs us to probe, not dismiss the possibility that 3I Atlas is a cosmic black swan poised to either fade into obscurity or rewrite everything we thought we knew. 3I Atlas is a cosmic enigma, captivating yet elusive, teetering on the edge of the extraordinary without fully crossing into the realm of the definitive. Its peculiarities draw parallels to the mysterious Oumuamua, another interstellar visitor that stirred debate with its elongated form, peculiar light curve, and baffling non-gravitational acceleration. Some, like astronomer Loeb, speculated Oumuamua could be a light sail propelled by the gentle nudge of solar radiation. Most, however, lean toward a natural explanation, a comet with unusual outgassing its acceleration, eventually attributed to specific vent configurations, though whispers of unresolved questions linger. 3I Atlas treads a similar path, its anomalies piling higher than those of its predecessor. Its chemical signatures, mass trajectory, and timing weave a tapestry of oddities, from its geometric quirks to its physical peculiarities. Natural explanations exist, but they demand a cascade of improbable coincidences, each requiring a carefully crafted just-so story. This makes the natural model less convincing, even if it remains the frontrunner. The stage is set for a cosmic reveal in November and December 2025, when 3I Atlas emerges from the sun's blinding glare, after weeks of obscurity having passed through perihelion unseen. 3I Atlas will slip far enough from the sun's radiance for ground-based telescopes to lock onto it once more. This moment promises the first glimpse of what transpired during its hidden journey. Did it coast through the solar system's heart unchanged, or did something extraordinary occur? Initial observations will zero in on its position. Orbital mechanics are unforgivingly precise given an object's position velocity and the gravitational forces at play. Its path should be predictable. Before vanishing behind the sun, 3I Atlas's orbit was meticulously tracked, its position measured repeatedly over months, anchoring its expected trajectory. When it reappears, astronomers will scrutinize its location. If it aligns with gravitational predictions, it likely sailed through perihelion following Newton's laws, no surprises. But any deviation, any shift beyond measurement error, would hint at forces beyond gravity. Non-gravitational acceleration, often linked to cometary outgassing, could explain such a shift. Earlier observations through September showed no detectable acceleration, suggesting an immense mass. Yet perihelion changes everything, bathed in intense solar heat. 3I Atlas could experience peak outgassing potentially strong enough to nudge even a massive object off course if the venting is sufficiently asymmetric. A trajectory shift alone wouldn't scream artificial. Comets with their chaotic venting from multiple surface points often experience small, unpredictable accelerations as their nuclei rotate. But if 3I Atlas veers in a precise direction, aligning toward a specific target, it raises eyebrows. Such a change would resemble a deliberate course correction, a hallmark of something more than a natural wanderer. Distinguishing between random outgassing and intentional maneuvering demands meticulous analysis. Astronomers will need to study the velocity change vector model, expected outgassing, based on surface temperatures and rotation, and compare these to observed shifts. This process, spanning weeks or even months, will determine whether the behavior is mundane or anomalous. As the analysis unfolds, December 2025 looms large, aligning with timelines flagged by researchers Serida and Loeb as potentially pivotal. On November 4, 2025, the European Space Agency's JUICE spacecraft en route to Jupiter's icy moons will pass within 64 million kilometers of 3I Atlas. Though designed to probe Europa Ganymede and Callisto JUICE's trajectory, offers a serendipitous encounter. Its cameras, spectrometers, and magnetometers poised to capture data from a unique vantage point. Unlike Earth-based telescopes, JUICE will view 3I Atlas from a different angle, enabling triangulation. If the object has fragmented into multiple pieces or exhibits unusual activity, jets, flares, or anything beyond typical cometary behavior, JUICE's instruments stand ready to detect it, adding a critical layer to the unfolding mystery. The data from JUICE, streaming back to Earth by mid-November 2025, will offer the first tantalizing clues about 3I Atlas's true nature. With the European Space Agency's mission in full swing and a track record of transparent data releases, unlike NASA's occasional silences during disruptions, the JUICE team's preliminary report should arrive swiftly. If they detect something truly bizarre, the world won't be left waiting long. Conversely, if 3I Atlas appears as an ordinary comet from JUICE's vantage point, it would calm the speculation, though not silence it entirely. A normal comet would be reassuring. But the mystery demands more than reassurance. It demands answers. On December 19, 2025, 3I Atlas will glide to its closest approach to Earth, a distant 269 million kilometers, roughly 1.8 astronomical units. While farther than Mars at its nearest, this proximity is a golden opportunity for observation. From massive ground-based telescopes to space observatories and even dedicated amateur astronomers with high-end gear, all eyes will be on the object. Its position in the night sky will be ideal lingering, long enough for multiple observations each night, offering a front-row seat to its secrets. If the nucleus is substantial and reflective photometry could pin down its size. If its still outgassing spectroscopy will unravel the chemical makeup of its plume. And if it has fragmented, a trail of distinct objects will stretch along its orbit, visible to those watching closely. By December, any fragments, debris, or hypothetical mini-probes released at perihelion would have had 2 months to drift apart. If bright enough, these could be resolved as separate entities, provided someone is looking with precision. Researcher Serida has circled December 25, 2025 Christmas Day as a pivotal moment, claiming 3I Atlas will align with Earth at the Great Pyramid angle. This geometric claim, based on the angle between the object and Earth relative to a reference point, is testable with orbital calculations. If the angle matches the slope of the Great Pyramid, it's a striking coincidence. If it doesn't, Serida's theory and his broader Fibonacci message interpretation loses weight. Yet, even if his prediction falters, Christmas Day remains significant for another reason: physics. If 3I Atlas released objects at perihelion on October 29th, propelled at 30-40 km/s, they could reach Earth in roughly 60 days, landing squarely in late December. Christmas Day falls within this window, making it a date to watch, not for esoteric geometry, but for the cold hard math of orbital mechanics. What might we see if probes arrive small meter-scale objects, if dormant would be nearly invisible, blending into the cosmic background until they breach the moon's orbit? Only if they emit heat signals or engine flares would they betray their presence at greater distances. Larger objects, tens of meters across, might reflect enough sunlight to be spotted within a few million kilometers by asteroid detection systems. But here's the unsettling truth: a deliberate approach could evade our gaze. A probe with trajectory control could lurk in the sun's glare, time its arrival for a new moon's dark skies, or coast on a low-energy path to mimic natural debris. Our detection systems, riddled with gaps, miss asteroids regularly. A stealthy probe could slip through unnoticed. If December passes without incident, if early January 2026 arrives with no unexpected visitors in Kiss lunar space, the probe hypothesis crumbles. 3I Atlas would likely be catalogued as an odd but natural comet, its chemical quirks folded into refined scientific models. The story would shift to a cautionary tale of overhyped speculation, a reminder to temper excitement with rigor. But if something does appear, something unexplainable, neither natural debris nor known spacecraft, the world changes overnight. Questions would erupt. What is it? Where did it come from? Is it communicating, observing, or hostile? Space agencies, governments, and militaries would scramble analyzing data in secret before any public word. Decisions would be made behind closed doors, leaving the world to catch up. Yet the saga doesn't end in December. On March 16, 2026, 3I Atlas will pass within 54 million kilometers of Jupiter, where NASA's Juno spacecraft, studying the gas giant's atmosphere and magnetic fields, will have a front row seat. Juno's instruments, sensitive to radio emissions, ultraviolet light, infrared heat, and magnetic fields, could detect anything unusual from signals to thermal anomalies. Astronomer Loeb, alongside colleagues Adam Hibbert and Anna Rippers, has urged NASA to point Juno's instruments at 3I Atlas, a call echoed by others in the field. From its unique perch, Juno could catch radio signals, if any exist, traveling unimpeded across the vast distance. The radio spectrum is immense, and stumbling upon a signal is like finding a needle in a cosmic haystack, unless it's meant to be found. Infrared data could reveal the object's thermal profile. A comet would show a predictable, warm sunlit side and cooler shadow. But internal heat sources or active systems might betray hotspots or stable anomalies defying solar patterns. As the months unfold, 3I Atlas remains a low-probability, high-stakes enigma. Almost certainly, it's just a peculiar comet, and we'll look back with a chuckle at our collective fervor. But almost isn't absolutely, and in that sliver of uncertainty lies a universe of possibilities waiting to be explored. From November 2025 to March 2026, the world will hold its breath as 3I Atlas commands a 5-month spotlight in the cosmic theater. This stretch of relentless observation, data collection, and analysis will determine whether this celestial wanderer is merely an odd comet or something far more profound. Yet, even as we prepare to watch a quiet unease lingers, we're piecing together a puzzle with missing pieces. High-resolution images remain elusive. The object's true size is still a mystery, and its chemical anomalies defy clear explanation. We're tracking something we don't fully grasp, hoping to predict its next move, and praying we'll spot the signs if the extraordinary unfolds. November's emergence from the sun's glare will reveal whether 3I Atlas's trajectory has shifted, hinting at unseen forces. December will bring its closest approach to Earth, a moment to scrutinize for fragments, probes, or anything approaching our planet. By March, Juno's data from Jupiter's orbit will add a final layer of insight. Come spring 2026, we should have enough evidence to close the chapter, declaring 3I Atlas a fascinating but natural phenomenon, or the herald of something unprecedented. Until then, we watch, we wait, and we hope our vigilance suffices. The question of human readiness looms large. In August 2025, astronomer Avi Loeb addressed the United Nations not in a grand speech before the General Assembly, but through formal written communications to scientific advisory bodies that shape policy. His message was clear yet measured. 3I Atlas's anomalies demand attention. International coordination is essential, and while panic is unwarranted, dismissal is reckless. The UN's response was polite but tepid. A diplomatic "we'll monitor the situation" devoid of urgency or action. No emergency sessions, no global task forces, just bureaucratic acknowledgement filed away for business as usual. Loeb also engaged US lawmakers, where Representative Anna Paulina Luna has been a vocal advocate, publicly pressing NASA for answers and endorsing observation proposals. Other congressional figures have shown private curiosity, but stayed silent in public, wary of the political risk. If 3I Atlas proves to be a comet, alarmists risk ridicule, a caution that stifles bold action. Yet, as Loeb argues, waiting for certainty is a trap. In high-stakes, low-probability scenarios, hesitation closes the window for response. The essence of risk management lies in acting under uncertainty, balancing limited resources against potential catastrophe. Loeb contends that the cost of monitoring 3I Atlas telescope time planning efforts is trivial compared to the chaos of being caught unprepared if something approaches Earth in December or January. Institutions, however, lean on precedent. History is littered with anomalies. UFOs revealed as weather balloons, signals traced to instrument noise phenomena, explained by conventional science. The track record of unusual equating to alien is nearly non-existent, fostering skepticism. When Loeb suggests this time might be different, the reflex is to demand proof, to assume natural causes until irrefutable evidence emerges. This is rational, grounded in centuries of debunked claims, but it risks missing a true black swan, an event so rare it defies patterns. 3I Atlas's 8 documented anomalies, from its chemical quirks to its trajectory oddities, don't neatly fit existing models. Each has a proposed natural explanation, but none feel fully convincing. Together, they hint at something just beyond our grasp, perhaps a gap in our understanding of physics or chemistry, or perhaps something genuinely new. Loeb's response to this uncertainty is a call to action. First, maintain relentless observation once 3I Atlas reappears in November. Track its position, velocity, brightness spectrum, and polarization with every available tool, building a robust dataset for analysis. Second, foster global cooperation. Share data instantly across observatories and space agencies, bypassing national or institutional rivalries. Agree on what constitutes an alert-level event, and establish secure communication channels to ensure rapid response. Third, prepare contingencies. What if the trajectory shifts in November? What if fragments appear in December? What if something approaches Earth? These scenarios demand pre-planned responses, clear decision points, and defined chains of command work that must begin now, not mid-crisis. Fourth, bolster observation infrastructure. Current sky surveys and cislunar tracking systems are inadequate, missing small objects at interplanetary distances. The upcoming Rubin Observatory will help, but a northern hemisphere counterpart, a large survey telescope scanning nightly for moving objects, could revolutionize asteroid detection and space situational awareness. Lowe estimates its cost as equivalent to a single military aircraft, a small price for immense benefits. Fifth, and most controversially, take the artificial hypothesis seriously. Model how an artificial object might behave, its signatures, its movements, and compare these to observations. If natural explanations fit better, fine. But dismissing the artificial possibility outright is not science, it's dogma. This final point sparks fierce resistance. Critics accuse Lowe of sensationalism, arguing that entertaining an artificial origin for 3I Atlas fuels fringe speculation and undermines astronomy's credibility. Lowe counters that true science embraces evidence even when it leads to uncomfortable territory. The stigma surrounding extraterrestrial intelligence in observed phenomena is a cultural barrier, not a scientific one. For decades, scientists exploring such ideas have faced ostracism, dried up funding, and career setbacks. Yet, as 3I Atlas weaves its enigmatic path, Lowe's call is clear: to ignore the possibility, however remote, is to risk being blindsided by the unknown. The coming months will test not just our telescopes, but our willingness to confront the uncertain with open minds and fearless curiosity. The scientific community's bias toward conventional explanations creates a perilous blind spot driven by an incentive structure that punishes bold inquiry. Even when natural explanations strain credulity, researchers cling to them, wary of professional ruin. This leaves us unprepared to recognize an artificial object in our solar system. What would such an object look like? What signatures, unusual trajectories, anomalous emissions, deliberate maneuvers would betray its nature? These questions remain unanswered, sidelined by the stigma of exploring extraterrestrial technology. Avi Loeb argues this must change. We need a rigorous framework to evaluate potential technosignatures, fearless researchers, dedicated funding for instruments tuned to detect artificial objects, and a cultural shift that embraces this pursuit as legitimate science, not fringe fantasy. Lowe's Galileo project is a bold first step, deploying observatories to scan the skies for unidentified aerial phenomena, UAPs, with cutting-edge sensors. Its mission isn't to prove aliens exist, but to collect data precise enough to distinguish natural phenomena, human technology, or something else entirely. Whether UAPs reveal as drones, balloons, or optical tricks, or hint at non-human technology, the knowledge is invaluable. Operating on a shoestring budget compared to mainstream astronomy, the project is a pioneering effort to normalize the search for extraterrestrial artifacts. If 3I Atlas proves artificial in the coming months, the Galileo project will shift from outlier to oracle, its foresight validated. But what if 3I Atlas is artificial? What if in December 2025 or January 2026, something inexplicable approaches Earth? The scenarios unfold with dizzying speed. First confirmation, multiple observatories must verify the object's existence and trajectory as a single anomaly. Won't suffice for a claim as monumental as first contact. Next, characterization. What is its size? Composition behavior. Is it transmitting signals or maneuvering deliberately? Every instrument, telescopes, spectrometers, radio detectors would be trained on it to gather a flood of data. Then classification. Is it a probe, a derelict relic, or an active spacecraft? A probe implies intentional exploration. A derelict suggests past intelligence, and an active craft raises the specter of immediate interaction or conflict. The question of communication follows. Do we signal it, risking a response we're unprepared for, or stay silent, observing cautiously? If 3I Atlas is a probe heading for Earth, it likely already knows we're here, rendering stealth moot. An automated system might ignore our signals, while a controlled craft could take years to reply depending on its operator's distance. The assumption it can or will communicate is a leap. Then there's defense. If deemed a threat, our options are grim. Earth lacks a robust space defense system. Ballistic missile interceptors designed for predictable slower targets are no match for an object hurtling at tens of kilometers per second on an unknown path. Nuclear weapons in space, lacking atmospheric shockwaves, rely on radiation and debris, potentially fragmenting a massive object like 3I Atlas into a swarm of smaller threats. The stark truth: we're unprepared to intercept or neutralize an extraterrestrial visitor. This vulnerability is sobering. If an artificial object approaches, we're reduced to observers, analyzing and hoping it's benign or indifferent. Loeb suggests that discovering extraterrestrial technology, even a derelict probe, could reshape humanity's priorities. The realization that we're not alone, not the apex of intelligence, might trivialize our border disputes, resource wars, and ideological clashes. A united front could emerge, driven by necessity to confront a cosmic reality. Yet history warns of division. Nations might interpret the event through competing lenses. Religious groups could proclaim it divine or demonic, and conspiracy theorists might ignite panic by accusing governments of cover-ups. Markets could collapse as fear overtakes reason, and chaos could erupt if our assumptions about reality shatter. Preventing such turmoil demands preparation we've barely begun. As October 2025 unfolds, 3I Atlas hides behind the sun, its secrets veiled. The next few months will decide whether we inhabit a solitary universe or one teeming with neighbors. Neighbors who might be friendly, hostile, or simply passing through, indifferent to our fragile blue world. Loeb's vision calls for action, relentless observation, global data sharing, contingency planning, and investment in detection systems. Above all, it demands courage to explore the unknown without fear of ridicule. As we stand at this cosmic crossroads, the question isn't just what 3I Atlas is, but whether humanity can rise to meet the possibilities it represents, or falter under the weight of our own uncertainty.